Good evening, my 11th standard warriors. Today we're going to start a new chapter, and that's momentum and collisions. So collisions happen everywhere, and there are so many examples that you can think where you can apply the theory of momentum and collisions. But today we are going to talk about impulsive force, non-impulsive forces, what is momentum, and also variable mass systems. And by the end of the chapter, which will probably take us 3 classes at least, you will be able to solve problems where you will be able to find what's the speed and the direction of a ball after another ball collides with it, and how much energy is lost, and so many other things. So all of this with me, Shreyas, your capto for this channel, teaching kids for more than a decade, producing so many ranks, and so many of my students are right now in IITs and even graduated from the top-notch institutes that you can think from the country. And I really hope that in the years to come, you too get really amazing ranks like my past students who have secured 2-digit ranks in IIT JEE Mains as well as Advanced. And if you want to know more about me, you can definitely follow me on my Instagram handle, that's Shreyas_Vedantu. Hi Saja, hello Anil, hello Gokulnath, hello Ishpreet, hello Roshni, Kedar, Suchi, welcome CBH, thank you Dinesh for all the love. Hello Narmada, welcome, Vanakam, hello Harita, good evening, this is your Capto. I'm very good, and probably some of you were there in your senior sessions where I was just counseling all of them. I hope listening to their queries and hearing those conversations, you are motivated to now get a very good rank in JEE, because the true power of a student is getting a good rank. Why? Because the moment you have a good rank, that is your tool, that is your power, because you can choose. You are the one who is going to dictate which branch and which college you want. Else you have to compromise. So it's a struggle for the next 2 years or 1 year, depending on whether you are in 11th or 12th. But that struggle is completely worth it. Your sacrifices, like you might give up on enjoying with your friends, or you might give up on a class, or you might give up on some hobby of yours, but it is completely worth it, because what you get after that is complete paradise. So let's get started. And if you have not yet hit the subscribe button, go ahead and hit the subscribe button down there. And if you have not yet smashed the like button, please do that right now. And many of our toppers have created history, and not just toppers, there are so many students who need to be celebrated. Many institutes just celebrate the toppers, but Vedantu is one of the very few institutes who celebrates each and every rank. And this year, in 2021, we created history by producing 3 times more results than the last year. Last year, we had 500 odd students clearing Advanced. This year, that number is a massive, big number, and that's 1,500 students. That means 6% of the students who are entering into the top colleges will be from Vedantu. Not just that, 60% of these students are from tier 2 and tier 3 cities. That means they are from towns and maybe even villages where they don't have proper access to quality education. So we are spreading and we are helping all the students who deserve that top-notch branch and college. And that's what the power of Vedantu is. You don't have to travel anywhere. And top 5% or 5% of the students in top 1,000 are from Vedantu. So that shows you the power of Vedantu, and it also is seen in the improvement that we create in the students, in the sense like there was a student by the name of Priyanshu who got more than 10,000 rank, and after joining Vedantu, his rank improved to 420. So bringing up an average student to the topper category or to improve his rank drastically is what Vedantu does. So we just do not concentrate on toppers, we concentrate on everyone. And if you want to be one of these stories, if you want to be one of these displacement stories, and if you want your choice branch and college, then you should definitely consider joining Vedantu, because there are plenty of offers going on right now. In fact, if you join even for 1 month and if you try it out, I'll be very happy about it, because I really want you to experience what Vedantu is. It's very different from what you get on YouTube. In fact, it is much better, I would say. And the batches start on Monday, and the price for per month is as low as 3,600 rupees to 3,000 rupees. So it depends on what packages you take. So just go ahead, check out the link in the description box below. The first thing that we need to talk about is momentum, and then we'll go to change in momentum, and then we'll go to impulse, and then average force, and then rocket propulsion and variable mass systems. All right, so let's gear up. Hi Chari, and welcome Chandan M. It's your first live class with me, and I'm so glad that you have seen many of my classes in the past. Nice to know that. Hi Magesh Kumar, welcome. Good evening Bacha Log. Welcome Zayed, and Dinesh is also a very proud student. Nice to know that. Very good. Let's get moving. So what is momentum? See, momentum is the effect of mass and speed. Imagine a motu guy. You might have seen a very motu guy in school and a very patlu guy, very thin guy in the school. Imagine both of them are running. Imagine both of them go mad and they go bang against you. Okay, so imagine a motu guy and a patlu guy, a thin guy coming towards you, and both of them are traveling with the same speed and they both bang against you. Obviously, who will impact you more? Who will create a greater impact? Who will knock you out more? Obviously, it's the bigger guy. But the smaller guy can also create a bigger impact if he travels with larger speed. Imagine the motu, fat guy, traveling with very small speed, but the small guy, the thin guy, the lean guy, the patlu guy is traveling with a really large speed. Then when they hit you, you will have probably similar kinds of impact. So that's what momentum is. Momentum tells you how much impact it can create, and that's the product of mass into velocity. So m into v, it's a vector quantity. It's a vector quantity, it's not scalar. Bear that in mind. That means it has direction. And what is the direction of the momentum? Imagine a motu guy traveling in one direction. Whatever is the direction of the velocity, the same direction the momentum will be. So whatever is the direction of the velocity, that's the same direction of the momentum. Okay, momentum and velocity are in the same direction. There is another way of writing momentum in terms of kinetic energy. You should know this formula. K is p square by 2m. Very, very popular formula. JEE Mains had asked so many questions based on this formula. How does this formula come? It's very simple, because kinetic energy is half m v square. Therefore, just multiplying and dividing by m, you'll get m square v square divided by m. But what is mv? mv is momentum, so it will become p square by m. So half p square by m is also a formula for kinetic energy. Is that okay, my warriors? That's something which you should know. Yes, Mahendra, please let me know whatever doubt you have. Hi, Surya. Welcome aboard. Yes, Motlu and Patlu. Crack with Gokulnath is the thin guy. Okay. So we need to travel really fast to have the same momentum. Is there any crash course for class 11th student, NEET students? Yes, Saja, there is a crash course as well. So just go below in the description box. There is a link. Click on that link. It will open up different courses. But on the top, you have an option to select for JEE and NEET. So just select NEET and just use the same coupon code. It will work. You will get offers and all of that. Okay. So yes, the same ball. Oh my God. Somebody remembers, sir, the same ball was used even in Newton's laws. Let me tell you, the same ball will also come in rotational motion when I show you rolling. Okay. Yeah. Very useful ball. I am not going to let it go. The next thing that we are going to talk about is change in momentum. Okay. What is change in momentum? See, if the magnitude or the direction of the momentum changes, because momentum is a vector quantity, the momentum will change. Example, imagine there is a car, it's going this way. It has some momentum. Even if it turns with the same speed, has the momentum changed? Yes. Why? Because the direction has changed. So momentum changes if direction changes, or if magnitude changes, or if both change. Another example is this ball. The ball was traveling here, a bat hits that ball, the direction changes, maybe even speed is changing. So again, the momentum of the ball has changed. Now what is change in any vector quantity? Change in any vector quantity is the final vector minus the initial vector. So simply put, change in the momentum is the final momentum minus the initial momentum. Now bear this in mind, because I have put a minus sign, you have to use vector subtraction. Very, very important. Remember, this is a vector, this is also a vector, so you have to use vector subtraction. Let me give you a simple example. Imagine a particle has initial momentum over here, okay, and let's say the final momentum is over here. This is the final momentum. Now when you have to do final minus initial momentum, what it means is, technically this is vector addition of the negative vector of the initial momentum. So take the initial momentum, negate it. So when you do the negation of the initial momentum, it will become like this. So this will be minus pi, and you have to add this vector with this vector. So your pf is over here, this is your pf, minus pi is over here, so this is your minus pi. So then this one over here, this will be your change in momentum. So that's how you get it using vector subtraction, which at the end of the day is nothing but vector addition of a negative vector. Everybody clear about this? So Kedar, you just started at 7:30, probably this lecture will go until 8:45 or 9ish, yeah? Okay, great. Very good, very good. So let's start with some questions coming up on your screen. Get ready, my warriors, starting with some easy ones, and then we'll go to the the average and probably the difficult ones as well. So what is the momentum of a body of mass 2 kg moving with kinetic energy of 100 joules? And if this body turns with the same speed, then will the momentum change or not change? And will the kinetic energy change or not change? Let's see how many of you can get this. Very good, Chandan, it is clear. Excellent day. Mahendra, whatever doubt you have, please let me know in the chat box. I'll definitely help you out. Okay, so what all do you know? You know the momentum. Oh no, you want to find the momentum, you know the mass and you know the kinetic energy. So the mass is 2 kg, kinetic energy is 100 joules, momentum is unknown. So I think I know what formula I should use. Kinetic energy is p square by 2m. That's the formula. So let's try and use it and see what do we get. Kinetic energy is 100, momentum is unknown, mass is known to be 2 kilos. So p square will be 2 into 2, 4, 4 into 100 is 400. So momentum will be 20 kg meter per second. So that's our answer. Is everybody clear about this? Okay. Now the second part is if it turns. Okay. So this is that car, and if it turns but it maintains its speed. If it maintains its speed, speed is constant, but direction, that is not constant. Now think what momentum is. Momentum is a vector quantity. So that means it has speed as well as direction associated with it. So if direction changes, momentum will also change. So momentum will be different. It will be different or it will change. That's what I will say. And kinetic energy is a scalar quantity. So because it is a scalar quantity, it will only depend on the magnitude. Now since mass is the same, speed is the same, half mv square will not change. So this will remain the same, it will not change. Okay, it will not change is what is the final answer. Is everybody understanding this, my warriors? Excellente. Yep, very good. Excellente. Excellente, Harita. Very good, Gokulnath, Chandan, Zayad. Very good, Molesh. Very good, my warriors. I just turned back and I saw all your chats. Very good, you guys have answered it correctly. So change and it remains the same, which is correct. Moving on to the next question. Now if I ask you a very simple question, probably it's an oral question. There is a car, okay, it was going like this, it turns and comes back. Let's say the speed was same. Don't you agree that the momentum will change, or do you disagree with that? Let's say there was a car going with some speed, maintaining the speed, it turns back. Speed is same. Will the momentum change? The answer is yes, it will change. And these kind of questions are very common. I have seen many people say, sir, momentum initially is mv, final momentum is also mv. Sir, mv and mv, sir, same, sir, momentum has not changed. That's where you made a mistake. Think about it. If initial momentum is mv, final momentum is not mv, it is minus mv. So that's why it has changed. Sign has changed. Be careful about it. And that's what the next question is all about. Okay, let's try to do this question. There is a molecule of mass m. It's an ideal gas molecule. It collides with a wall of some vessel with some speed v, but somehow it returns back with different speed, half the speed for some reason. Okay, the change in the linear momentum of the molecule is how much? How much is the change in the momentum? That's the question. Let's see how many of you can do this. First start with a diagram and then probably we'll get it very easily. So here we have this molecule of mass m moving with speed v, and it collides with the wall of a container, and eventually it returns back. That same molecule returns back, but with a speed which is half of the previous speed. So the question is, what is the change in the momentum? Okay, the question is, what is the change in the linear momentum? So change in momentum is final momentum minus initial momentum. Now think about it. Final momentum, okay, final momentum is mass into speed. So, but it is on the left side. Remember, this side is positive, this side is negative. So this will be minus mv by 2. Minus initial momentum. Initial momentum will be mass into velocity. Okay, so this minus mv. So what are you going to get? You are going to get minus 3 mv by 2. So that's the change in momentum, but magnitude wise it is just 3 mv by 2, because all the answers are positive. So I think I should go with the third option. How many of you said C? Very good, very good. It is not half mv, be careful. Yep, it is 3 mv by 2. Yep, yep. So Zahir Rahman, we are a JEE focused and JEE oriented channel. We do not take care of BSc, but if you are aiming for BSc, then this channel will be helpful, because you will be preparing for JEE and competitive exams like KVPY, BITSAT and other examinations. Okay, great my warriors, excellent day. Let's move ahead to the next question. 3 mv by 2 was the correct answer. Now let's talk about impulse. What is impulse? And let me tell you, many people do not know what impulse is, and you will see why when we ask some questions. And also people get confused between impulse and impulsive force. Okay, let me tell you what impulse is. See, look at this batsman. There is a ball which is coming. He hits the ball, the direction changes and probably the speed changes. So the momentum has changed. So that quantity which depicts the change in momentum is just called as impulse. As simple as that. So what is impulse? Strictly speaking, it is nothing but change in the momentum. That's it. So change in the momentum. Now, if you think about it, by the way, the symbol for that is I or J. Some books use J, some books use I. It's one and the same thing. It's a vector quantity. Okay, very, very important. It is a vector quantity. So it has both magnitude as well as direction. And because I said it is change in the momentum, so it is delta P. So whatever is the direction of delta P, the same is the direction of J or I, which is the impulse. And we just saw what is change in momentum. It is final minus initial. So impulse is just change in momentum. Now let me remind you of one more thing. If everybody is clear to this point. Impulse is just change in momentum, which is final minus initial. I just showed you how to calculate it. Now, from Newton's laws, you all know force is rate of change of momentum. So if you have force, then it is change in the momentum upon the time taken to change the momentum. Is that right? So how about writing delta P as F delta T? So I can write it as F into delta T as well. So both formulas are fine. So you can write impulse as change in momentum or force into time. Both formulas will give you the same answer. Which one to use when? Depends on what is given. If force is given, time is given, then probably you'll use this. If you know velocity, mass, then probably you'll use the first formula. Correct? Clear? But this can be only used if the force is constant, not otherwise. Let me tell you. This can be used if this force is constant. Then you'll be like, sir, then what to do, sir, if force is not constant? Think, what will you do? Force into time gives you change in momentum. What if the force is changing? Then at every instant, I have a new value of force. Force at that time into a small time. Force into a small time will give me the small value of impulse dj. Wow, dj rocks. Okay, so dj is the small impulse given by the force acting for that time interval dt. Next instant, new force, new time interval dt. Every time fdt will be new impulses at every instant of time. Yes, already people have told it. Very good, Suchi, Chandan, Harita, Roshni, you got it, Gokulnath, very good. So Harsaran, it's very simple, bacha. If you start early, you get long classes. If you start late, this. If you start even late, this. So it has to be true because your exams are at the same time. You cannot say, I will start late, sir, and I will end the portion here. And how will it be possible? So if you start late, obviously the content will be same only. Obviously everybody will teach you the same thing, but you will have little bit lesser examples. The portion will be little bit more on the crash side. Yep. So you'll have to do integration, and therefore the total impulse will be, by the way, f dt integral. So this is what you will use if force is not, if it is not constant. Very, very important. So if it is not constant, then use integral. Fair and simple. Great. Chalo. So what is impulse? Impulse is change in momentum. It is delta p. It is f delta t. If f is constant, and if it is not constant, integral f dt. Very simple. Should we write dt by dl? No, Suchi, why should you write it? Nope, you don't have to. Okay. Rani C, can you do one thing, bacha? You can do one way. You ping me on Shreyas_Vedantu or leave a comment after the video ends. I'll definitely help you out. I'll respond to your comment. And if you have seen my previous videos, I always respond to all the comments. Now, the moment you see integration, you should always think of area. This should be there in your head by default as a rule. Integration, area. Derivative, slope. Always remember this. The moment you see integration, area. But area of what and what? Force and time. Area of force and time gives you impulse. So if you draw a graph of the force acting on a body and time, with time, the force could change. Maybe it goes up, goes down. The area under that force versus time graph gives you the impulse. But bear this in mind that, let's say for example, this is force, this is time, and the graph goes like this and like this. So when you calculate the area over here, this area is positive area and this area is the negative area. So the area of force versus time, because I just told you integral f dt is nothing but impulse. So integral means area. Keep this in mind. Will be useful for solving problems. Yeah. Now let's actually talk about what is impulse and what is impulsive force. Because many people do not know the difference. See, I just told you one thing. That, in general, if you talk about impulse, it is force into the time. Imagine there is a block or a particle of mass m and there is a force acting on it. And it acts for a short time. So it acts for a short time. And you find that this particle gets good amount of velocity. Okay, it gets some velocity. Now if this velocity is very large or decent, it's good velocity. Okay, if this is large, okay, then this force, even though it acted for a small time interval, it has changed the momentum by a large amount. So then I will say that that force is impulsive in nature. What is that force? That force is impulsive in nature. Now, imagine another force acting on the same particle for a very small interval. But when it moves by that small amount, you see that the velocity does not change. Let's say the velocity is less. Then that force is non-impulsive in nature. Force is impulsive. Impulsive is an adjective over here. Please understand. Force is a noun. This is more like an adjective. Impulse is different from impulsive. Impulse is change in momentum. Impulsive is an adjective to describe the force. The force can be impulsive or non-impulsive. Let me give you simple examples to understand this. Okay, imagine there is a bullet, it strikes a glass and it hits the glass and it breaks into pieces. All these particles would have got tremendous momentum, and remember that bullet would have exerted a very large force on the glass particles, correct? And it was in contact with the glass for a very small amount of time, because this simulation is a slow motion. Okay, it's not in true speed. You can see the bullet was hardly in contact for any time, and you can see the glass particles just spread across. So good amount of momentum in a small time. So will the bullet force be an impulsive force? Yes, it is an impulsive force. Okay, I'll give you another example. I get very angry. There is one badmash student. There is one, okay, evil student. I do not do that, but I'm just saying. Get very angry. Shreyas sir got very angry. Call that student. And I'm like, dishum, punch. That force will be impulsive or non-impulsive? Come on, think about it. It will be impulsive force. Or you are calling your friend. He is not ready to come. He's like, no, I will not come with you. Your friend is very angry. So you hold his hand and pull him. So your friend is just like, I'm not going to come. You hold his hand and you pull him. Sudden jerk. That is impulsive force. Another guy, he's pushing you slowly. Move, man. Please move. Okay, he's pushing you slowly. He's trying. And you're still not moving. You hardly move. That is non-impulsive in nature. Hardly any change in momentum. Even though the force acts for a decent time, it couldn't change the momentum. So impulsive is decided whether it can change the momentum in that short time or not. So look at this. Okay, so non-impulsive force are those forces which act gradually on a body. For example, gravitational force or spring force. So imagine you're holding a ball. So when you're holding or catching a ball, you hold it like this. You are applying that force decently for a large time. You're taking time to change the momentum. It's a gradual absorption of that momentum. So that is a non-impulsive force. If you put a spring, that spring will slowly absorb that momentum. All these slow forces are generally non-impulsive. Understood? Hello, Chitra? Yep. Okay, chalo. Let's get moving. Yep. Right. All right. Okay, no problem. Even if you have an exam, you can watch the replay. And Ganga Devi, the only motivation you need is by seeing others. Look at the energy of others, man. Just look at how others are answering the questions. There are some 9th standard kids also over here. So derive the motivation from them and always set a target. Maybe you can have a dream of IIT or dream of a branch or dream of something. I don't know. You want to become an IAS officer or you want to become a very top-notch engineer or you want to become a top-notch industrialist. Set a target or a goal. Automatically, all the cells in your body will start working for it. Okay, chalo, let's get moving. Hi Saitej, welcome aboard. Chalo, let's see how many of you can solve this question coming up on your screen. And the question says a ball is hit with a 300 Newton force. High-speed cameras show the contact lasted for 0.02 seconds. What do you think was the impulse? Interesting question. So there is a ball, okay, this ball was hit and the contact lasted for how many seconds? 0.02 seconds, and the force which was acting on it was 300 Newton. So the question is, what is the impulse? You just got it sometime back that impulse is the effect of force into the time for which it acts. What is the force? 300. What is the time? It's 0.02. So 0, point gets cancelled. 3 2s are 6. So 6 Newton second or 6 kg meter per second. Both are same unit wise. Either you can use Newton second or you can use kg meter per second. One and the same thing. Okay, straightforward question. Excelente. 6 is the answer. Yep, it is. Moving on to the next question. Let's see how many of you can do this. Very good Chandan, Muhammad. Very good Harita. Very good Molish. Very good KSK. Excelente. Very good KSK Ritika, if you're not able to see my classes in the pro subscription, I'll tell you very simple trick. Just leave a comment after the video. I'll tell you the names of the courses which I'm teaching, and you can just search for it and you will get it. Those might be recorded, or some of them could be live, but you will be able to see all my courses. I'll just show it to you. Just leave a comment. I'll tell you exactly what you should search for in add more courses. So go to micro courses, add more courses. You will be able to search for my courses over there. Okay. KSK Kritika, fine. All right. Hi Zayed. Yeah, I hope you're alive, and I see you have changed your display picture. When are you going to change your display picture to JEE Enthuse? Okay, do that. All right, come on. Let's see how many of you can do this question. You have a graph, and the question says, what is the impulse at 2 seconds? This is position time graph. Be very careful. Do not try to find the area. If you're trying to find the area, probably you will get the wrong answer. Okay. Let's see how many of you can get this. This is position time. The question is, what is the impulse at 2 seconds? Okay, impulse at 2 seconds can be found out by how much does the momentum change, before 2 and after 2. Okay, so before and after 2, let's just try to think about it. Final minus initial. Over here, you can see position is not changing. In fact, the graph is horizontal. In fact, the velocity finally is 0. Can you see that? When the graph is flat, the slope is 0. Position time graph, slope is 0, velocity is 0. But if you look in this part, you can see that it is constant. So what will be the initial velocity? Think about it. Before 2 seconds, it moves 4 meters in 2 seconds. 4 meters in 2 seconds. So 4 meters in 2 seconds, that's 2 meters per second. So you can see final momentum will be 0. Initial momentum can be calculated using this speed. So final momentum is 0. Initial momentum will be mass. What's the mass? Is it given? Yes, it is 0.1 kg into velocity, which is 2. So the answer will be minus 0.2 kg meter per second. And is that there somewhere? Yes, it is. Option B. Is that clear? Very good, KSK. Very good, Molish. Very good, Roshni. Very good, Mohammed Salim. Excellente. MD Riaz, can you crack your 2023 exam if you start preparing from now? Well, ideally, you should have started a long time back. You have missed almost like 4 or 5 months of preparation. I have already reached, Momentum and Collisions chapter. But if you work a little bit harder for the next 3 months, try to cover the backlogs. Yes, you can target for 2023 exam, but you need to really have a very good timetable and very good strategy, and make sure that you follow the timetable for the next 3 months. So you will take at least 2 to 3 months to clear the backlogs. It won't be cleared within 1 or 2 weeks. So set small goals. Trust me, you can complete it. Don't worry. Yep. Thank you, Ira Shaukat. Okay. Moving on to the next question. Okay, answer was B. Wow, we have a graph. And let's see how many of you can solve this question. We have a force in Newton versus time graph. And the question says, what is the impulse in the first 7 seconds? Okay, just mark it and see if you can get the answer. If you are unable to see which one is what, I'll just mark it for you. 1, 2, 3, 4. And this is 5, and this is 6, and this is 7. Interesting. And then, okay, the y-axis, you have -2 here, and this is -4. Okay, so if you want to find the impulse in the first 7 seconds, all you need to do is find the area under the force versus time graph in 7 seconds. Now, if you look at it carefully, you will see there is a triangle on the top. So I need to calculate this area for sure. Okay, and this area will be half into base, which is 4, into height, which is also 4. So 2 into 4, that is 8. Clear till this point? So 8 is the area of the upper triangle. Then what is the area of the triangle over here? Well, let's calculate this. So this area will be negative because it is below. So again, half into base, 4 to 6, it's 2 units, into height, height is 4 units. So into 4, so that is going to give you -4. 6 to 7, there is no area because it is flat. So ignore that. So hence, this area will be +8 plus -4. So that is going to be just 4 units or 4 kg meter per second. That's the answer. Understood? Clear? Very good. How many of you wrote it? Very good, Chandan. Excellent, Harita. Very good, Suchi. Very good, Krishna. Very good, Gagan Devi. Very good, Molesh. All right. Very good. Very good. So, Kedar, if you're not able to study continuously and if you want to take breaks, yes, please take breaks. But make sure your breaks are non-distractive. So, the break should actually regenerate you. It should also help you become refreshed. So, the break should not be something where you get distracted, like say you're watching a movie or watching a series. So that's not a good break because it will try to corrupt and pollute your mind. So do something which is creative, like painting or music or cycling or exercise or music, something like that. So that will help you regenerate. You'll actually feel refreshed. You should not feel drowsy. And try to study and wake up in the morning. Automatically you'll start feeling more active. Okay, next question coming up on your screen. And here it is. Is impulse also considered as a vector? Yes, impulse is a vector. Remember, impulse has the same direction as that of change in momentum. Impulse is change in momentum. Change in momentum is a vector because it is calculated using vector subtraction. So yes, impulse is also vector. You are 60 kg. You run at 3 meters per second. And you hit a wall. My goodness, that's crazy. It will hurt a lot for sure. Okay, so imagine there is a Pandu over here, and that Pandu, I don't know, he goes mad. This is a 60 kg Pandu. What is this 60 kg Pandu doing? He runs like a fool, like a mad boy, and he bangs himself against that wall, and he stops in 0.02 seconds. First case. Second case, the wall is padded. That means there is some soft material over there. Okay, so case A, it's a wall, and in the second case, there is some padding over here. There is some soft material, cotton or wool or some sponge is there. So because of which he stops in slightly more time, 0.5 seconds. In which situation is the impulse higher? Let's see how many of you can get it. Semuzi, the cool name, Suresh Kumar. Yes, you told. It's got some meaning in Tamil. Yeah. Welcome. You're a little bit late. Okay, so Roshi says A, Molesh says A. And what about others? NIT does not offer aerospace, bacha, but after EEE, if you want to go to aerospace, yes, you can go into avionics, instrumentation for aerospace and all of that for higher studies. Yes, you can do that. Okay, everybody is saying A. So who offers more impulse? Well, I'll tell you what, the answer is same. You guys are wrong. Same in both the cases. Now you might be wondering what the hell just happened. So let me tell you, in the first case, this Pandu went and banged against the wall. In the second case, the same Pandu, same mass, same speed, he banged against that wall, but the wall had some padding over here. If I ask you what is the impulse in the case A, it will be final momentum, which is 0, minus m into v, which is basically minus mv. Correct? Now the same Pandu in the second case will go and bang against the same wall. He stops. So final momentum is 0. Initial momentum will be mv. So change in momentum or impulse is minus mv. So in fact, the impulse is the same. Now you might be like, sir, I'm not convinced, something is going wrong. I'll tell you what is going wrong in your head, and that is your gut feeling. See, impulse is same. This answer is correct. But remember one thing, impulse is force into time. So in the case of A, the time was less. So when time is less, the force is more. And when the time is more, the force is less. The question does not ask you the force. The question asks you the impulse. Yes, in the first case, when you bang against the wall, the force will be definitely larger. The force that you will experience will definitely be larger. But in the second case, you are slowly stopping, so the force will definitely be smaller in the second case. So if the question was the force, then answer A will be correct. But the question is impulse, that's why both answers or both impulses are the same. Is that now clear? Yep. Is that clear? Yeah. So that's a very, very tricky question and many people fall for this trick. So that's why you need to be very careful. Physics is not always about gut feeling. It's also about actually trying to solve using mathematics and the laws of physics. And if you're enjoying this session, do not forget to smash the like button in case you haven't done that yet, to show your love and support. And yes, if you're not yet subscribed, please hit the subscribe button down there. Okay, that's your small Guru Dakshina for me. Okay, next question coming up on your screen now. Selva, you missed some amazing questions and amazing concepts. You can rewind back and you can catch up at 2x speed, let me tell you. Okay. So Amit, if you are particular about CS into IIT or IIIT, then you need to get very, very good rank. You should be in the top thousands. That's what I would say. Yeah, top 1000, top 1500 for IIIT and IIT. Okay, so there is a pool ball and it hits a surface with a speed of 10 at an angle of 37 degrees with the normal. Okay, so this angle over here is 37 degrees and it bounces off a smooth surface at 45 degrees. So this is 45 degrees. This speed is given to be 10 meters per second. Now let me just assume some convention. Let's assume this as our x-axis. Let's assume this as our y-axis. Now you can see I can write the momentum in I cap, j cap and initial and final both, and I will somehow try to figure out what is the impulse by the edge. The reason why I will do it in I cap and j cap is because I see that the ball is falling at an angle, reflecting at an angle, so clearly it's a 2D problem. So because it is a 2D problem, I will obviously try to solve it using vector notation because it is going to make the problem very easy. Let's do this. Yep. Now, first of all, this velocity will have two components. One component here and the one component over here. If this is 37, obviously this is also 37 and this will be 10 cos 37. What is cos 37? Cos 37 is 4 by 5. So obviously this will be 10 into 4 by 5. So 2 into 4, that's 8 meters per second. This component will be 10 sine 37, which is 10 into sine 37 is 3 by 5. So this is just going to be 6 meters per second. So what did I get? Initial momentum vector wise is how much I cap? 6 I cap. Can you see that? 6 I cap minus, why minus? Because it is going against the y-axis. How much? 8 j cap. This is the velocity, the whole thing into the mass. What is the mass? It weighs 0.5 kg. So this thing into 0.5, this many kg meter per second. So this will become 6 into 0.5 is 3 I cap minus 8 into 0.5 or 8, half of 8 is 4. So minus 4 j cap kg meter per second. So this is your initial momentum. Fair enough till this point? Everybody clear about this? Very good. Why are we using unit vectors here, Gokulnath? The reason is unit vectors makes it very typical, analytical to solve the problem. I mean, there will be no confusion. You can solve it via geometry also. But if the angles do not turn out to be good, or if the geometry comes out to be slightly more complicated, you might take more time to solve. But if you are already conversant and if you find resolution of vectors very easy, then I think you should go with I cap, j cap. It will be very easy. No, Selva, is this under laws of motion? Well, in NCERT, the chapter flow is different, but in JEE, like if you follow H.C. Verma and any other popular IIT book, you will see momentum and collisions is a separate chapter from laws of motion. Okay, I hope this much is clear. Now, look at this word. The word used over here is smooth surface. Because it's a smooth surface, when the ball hits the surface, understand this ball will only experience a force in the perpendicular direction. There will be no force of friction. The frictional force will be 0 in the x direction. Everybody agrees to this fact? Because the word mentioned is smooth. That means the momentum along x is basically same. Everybody getting this point? The momentum along x will be same because there is no force in the x direction. If there is no force, how can the momentum change in the x direction? So hence, I can say that the final momentum will still be 3I cap, but j component will change. But there is a good thing over here. Since the angle is 45 degrees, don't you see these two components will be equal? So can I say this px component and py component both will be equal because these angles are 45 degrees, 45 degrees. Don't you see that, guys? Everybody clear about this? So this is 45, this is 45, both components are equal. So if this is 3I cap, obviously this will be 3j cap in the vertical direction. Understood? Oh? Clear? Such a nice trick. So because the angles are 45, I can find it out very easily. Even if it was different, I can still do it using trigonometry. That's not the big thing over here. The crux of the problem was to understand the x momentum won't change. Only the y momentum changes. Now it is a very simple problem. The question is, what is the impulse? Impulse is final momentum minus initial momentum. So final momentum obviously is 3I cap plus 3j cap, okay, minus initial momentum, that's 3I cap minus 4j cap. Anyways, you can see very clearly the x momentum got cancelled. Why? Because the x component did not change. I want you to see that very, very clearly. The only thing that has changed is the j component. Minus of minus is plus. 3 plus 4 is 7 j cap kg meter per second. That's the answer, my warriors. Is that clear? What a lovely question. Very good. Very good. Very good. Very good. Vicky, how about this? Why don't you leave a comment after the video ends? I'll definitely respond to your counseling comment regarding aerospace. All right. Chalo. So that's the answer, 7j cap. Beautiful two-dimensional question. Now let me tell you, those of you who have still not joined our classes, probably, and if you don't have enough material for practice, make use of this Tattva material, which you will get it when you join our classes. What is Tattva? Tattva is a combination of problems, concepts, summaries, important points, facts, easy problems, difficult problems, previous year mains, previous year advanced. So you get this book for physics, chemistry, maths, bio, and for different chapters you get these books couriered to your home address. And this book has so many problems from easy to hard. It actually has built confidence in so many students. So make sure that you join the pro subscription, and you only then you will get this book, because there is no other way of getting this book. And you practice all the problems from this book and HC Verma and your standard textbooks. Trust me, your problem solving skills will improve multifold. Okay, so that's your Tattva material. It has everything, and whatever I am teaching today, you will get it in the Telegram channel as a PDF. So go ahead, join our Telegram channel link as well. Now let's go to the next part, and that is average force. Sometimes it happens, some body strikes another body, or you hit somebody, or somebody applies a force on another body, and that force is not constant. Example, look at this. The force changes, it increases, decreases. It could be anything. Okay, so you might have some random graph like this. This is my force versus time, and let's say the force changes like this. Okay, it's a variable force. It's a variable force. I want to know what's the average force acting on the body. What do I want to find? I want to find what's the average force acting on the body. What is the meaning of average force? Average force, okay, it produces the same impulse, as that of the variable force. That's what average force does. It is constant force which produces same impulse as that of the variable force. How much impulse does the variable force produce? Just calculate the area. Okay, this is the area under the graph. Till here, let's say this is T. This area. How much impulse will a average force produce? So average will be somewhere in between over here. So maybe like this. So this is my average force, and this area will give me the impulse produced by the average force. Is that clear? Think about it. So the green area gives me the impulse produced by the average force, and the red area gives me the impulse produced by the variable force. Everybody clear about this? Now think, what is the area of the green graph? What is the area of the green graph? Because it is a rectangle, shouldn't it be average multiplied by time? Shouldn't it be average force multiplied height into length or width into length, whatever you want to call it? This is the area of the rectangle. What is the area of that variable graph? It is integral force with respect to time. That area under the red graph is integration of force with time. So I think I found out the formula for the average force. So the average force is equal to nothing but integral force with respect to time upon the time itself. As simple as that. Okay, so this is the formula which you are going to remember. This is the formula which you are going to remember. But remember one more thing, you can avoid the integration just in certain cases, because integral force with respect to time is nothing but impulse. Correct? It is nothing but impulse. So you can might as well write it as impulse divided by time. So this is also the correct formula. Force with time integration is impulse. So impulse by time is also the average force. So what is average force? Average force is that average value of that force, which is basically a constant force which you can apply to produce the same impulse. Okay, so if you have a variation of forces, then that same force will give you the same effect, that is the same impact as the same impulse as that of the variable force. Formula is impulse by time. That's all you need to remember. An impulse is integral f dt and the whole thing divided by time. Okay. Sengage Muhammad, I don't like Sengage for physics. Maybe for maths it is good, but physics, please don't use Sengage. It's probably not going to build up your IQ. It's not going to build your problem solving skills. So generally I have found students who solve Sengage, their problem solving skills do not improve over time. So some students can, maybe it works for a few students, but most of the students it does not work. Probably you should switch to DC Pandey, Tattva, HC Verma and previous year questions from Arihant or Disha publications. Okay, so let's start solving some questions coming up on your screen right now. Yep, very good, very good. So let's go ahead. Prithvi Agarwal, if you have completed your pro course, what should I do now? Don't worry, Prithvi. Revision course is going to start in pro subscription now. So if your batch is over, in the next 1 or 2 weeks, just after Diwali, revision is going to start. So meanwhile, utilize this time to prepare for KVPY examination in case you have registered for it. Okay, we have Jennifer. And what is she doing? She has a mass of 50 kg, my God. And she's riding at 35 meters per second and in a red sports car. Okay, so meanwhile you read the question, let me draw Jennifer in a red car. Okay, so this is Jennifer. She has long hair, she has beautiful eyes, and she's wearing a red lipstick. Was it mentioned in the question? Oh, it is. Oh, it's a red sports car. Oh, not about the lipstick. Okay, so let me just draw that sports car. So that is Jennifer's sports car. Okay, red color sports car, and she's over there. Interesting. Okay, very good. And what is she doing? She sees a deer and she slams on the brake. Okay, so we have a deer over here. Okay. Okay, this is our deer. Very beautiful deer. This is how it is. She sees the deer. And what does she do? She slams the brakes. Very good. To avoid hitting the deer. But because of that, you know, there is an airbag which is released from that. You know, that airbag and everything, it brings her body to a stop in 0.5 seconds. What's the average force the seat belt exerts on her? So basically, you know, everything comes to a halt. There is retardation which is happening. The question is, what is the average force on her? So obviously there is retardation. There is obviously retardation. or deceleration, and obviously there will be a force to retard it. So that force on Jennifer, okay, let me just put Jennifer over here, will be responsible for changing the momentum. Basically, I can say it is impulse upon the time interval. Remember that force is impulse by time. I just told you this formula. That's it. And what is impulse? It is change in momentum. So it is final momentum minus initial momentum upon the time interval. What's the final momentum? Because she comes to a halt, it is 0. Initial momentum, mass, which is 50, into velocity, which is 35, divided by time. What is the time? It is 0.5. So this will become minus 5 goes. So this will become minus 100 into 35. So it will become 3500 with a negative sign. So that's your average force in Newton. That's the final answer. If the question says magnitude, then the answer will be 3500 Newton. That's crazy. Very good. Very good. Excellent. Yep. Minus 3500. Very good, Harita. Very good, Chandan. Excellent. Hi, Raji. Welcome aboard. Okay. Very good, Prithvi. Nice to know that you will start it. Is there a 11th standard crash course for JEE? Yes, Vijay. There is a 11th standard batch which has just started, and I think there's one starting on Monday. So you can go ahead and join it right away. Don't waste any more time, because a lot of students have made the mistake waiting. They are having faith in their coaching and thinking that everything will happen, or just relying on self-study and then realizing that, okay, it's not working. So better late than never. Start off your course right away. There is an offer going on, and that's incredible offer. Please try it out for 1 month. Buy that 1 month course. If you think that, oh no, I don't want to pay for the entire year, just go ahead, try it out for 1 month. There is a link in the description box. Okay, so Vijay, the link is in the description box. Okay, you can check it out. Just wait till the end of the class. I will show you how to join it. Okay, not now. All right, next question coming up on your screen, and here it is. Yeah. Okay, so here we have the net force acting on a body which varies with some function, and that is minus 3t square plus 6t. F is the force, t is in seconds. What is the impulse on the body during the time interval 0 to 2, and what is the average force acting on it? Okay, let's start solving it part by part. Force is given, time is given. Question is, what is impulse? Second thing to notice, force is not constant. And I had told you, when force is not constant, then the impulse has to be calculated by integrating force with respect to time. Okay, so what is impulse? The force is given over there. So integral minus 3t square plus 6t dt, but the limits have to be put because the force acts from 0 to 2 seconds. So lower limit will be the initial time, upper limit will be the final time till which the force acts. That's what you will do. Okay, now split the integration, because there is a plus sign. I can split it, and whatever numbers are there, I can bring it outside the integral. So minus 3 integral t square dt from 0 to 2 plus 6 is a constant. What remains is just t dt, again from 0 to 2. Now what will you get? Minus 3 t square's integral will be t cube by 3. So t cube by 3, and limits will be 0 to 2 plus 6. T's integration is t raised to 2 by 2. So t square by 2, again from 0 to 2. So this will become 3 cancels. So minus 1 into, put 2 first. So 2 cube minus, then put 0 over here. Plus 6 into, put 2 first. So, oh, wait a minute. This 2 and this 6 will get cancelled. So you will just have 3 over here, and 2 square minus 0 square. So what am I going to get? Just check this out. J will be equal to 2 cube is 8, so minus 8, and 2 square is 6. 2 square is 4. 4 into 3, that's 12. So plus 12. So that is going to give you 4. So J will be equal to 4 Newton second or kg meter per second. How many of you got this? Yeah, definite integral, correct. Yeah. Prithvi, it will come soon, bacha, after the second term starts. I can't have the Erodo course right now. Okay, first you should be conversant with your term 1 syllabus. You should reach at some level. Meanwhile, you can watch my problem solving course for 12th standard. I have completed all the term 1 chapters right from electrostatics to AC. Beautiful problems which will blow your mind. So attend that course, you can search for it. Zayur, the price for 1 month is around 3,000 rupees or even less. Just apply the coupon code and you will see it. Okay, I'll just show it to you towards the end of the class. Okay, this is the first answer. Now let's go to the second one. What is the average force acting on it? So average force, I just told you, it is impulse upon time. What is the impulse? 4. What is the time? It is 2. So hence the average force will be 2 Newton. That's the way to calculate it. Very good, Chandan. Excellente. Vijay, virtual high five you want? Here you go, virtual high five. I hope it is not looking like virtual slap. All right. Chalo, let's get moving to the next question coming up on your screen. Oh, we are slowly entering rocket mechanics. Interesting. Okay. So Rani Mishra, I'll tell you, for KVPY, you do not have theory classes separately. Use the theory classes of IIT JEE only. There is nothing like special theory class for KVPY. It's the same thing. Newton's laws will remain Newton's laws in KVPY. It won't change. So जो मैंने nurture या pathfinder या 11th या 12th में पढ़ा है, same lectures का इस्तेमाल करो. Only the type of problems are slightly different. That's why you will find a separate playlist for KVPY. Okay, Rani बच्चा? चलो. Let's solve this question. You can see a beautiful rocket engine and gas is ejecting out of it. And the question over here is, if a fluid, a gas or a liquid, is ejected with a speed v and the cross-sectional area is A and the density of the fluid is rho, find the thrust force. When you eject the gas, don't you agree there will be a thrust force acting on it? Everybody is able to visualize this. Or when you are holding a pipe through which water is coming, you feel a force backwards. If you have seen Tom and Jerry or cartoons, you might have seen they hold a fire extinguisher pipe, a hose, and water comes out of it. And Tom and Jerry, they start flying in the air because of the thrust force. Or you take a balloon and open its mouth. The air which gushes out pushes the balloon forward. So liquid or a fluid of density rho comes out with speed v through an area of cross section A, which creates a thrust force. That's what it is. Now let's try and solve this question. Now this formula you should remember for sure. Oops. Okay. So the way I'm going to solve it is, whatever force is exerted on the liquid or basically on the fluid will be the force which is exerted by the fluid as well, and this force is called as the thrust force. This is exactly called as the thrust force. So imagine if I take the fluid which was inside of this, I don't know whether you can see this clearly, but maybe I'll draw it here with a different color. Initially, this fluid was at rest. Let's say the mass is dm. That fluid was at rest over here. Okay. What happens is, it is forced out of that jet engine and it comes out over here, and that same mass dm now has some speed v. It's coming out with speed v. Earlier inside the engine it was at rest, the fluid burns and is propelled outside the engine with speed v. In time dt. So if I want to find that force, I know what I need to do. Force is rate of change of momentum, dp by dt. Change in the momentum is final momentum minus initial momentum, correct? What is the final momentum? Mass into velocity. That means dm into v minus, what is the initial momentum? Can you see it was at rest? So minus 0 upon the time taken is dt. Everybody clear about this? Fine. Next up, what is the dm mass? The mass which I'm talking is that dm mass, which is a thin slice of mass. That mass, can I say it is density into volume? Because density is mass by volume, mass is density into volume. So can I say it is nothing but density into the volume, okay, into the volume into V, the whole thing divided by dt. Okay. Now what is the volume of that thin thickness? What is the volume of the thin thickness? Think about it. What is the volume of the thin thickness? That volume will be area of cross section. I'll make you visualize this. This is the dm mass. Okay. It has got some area over here and some thickness dx. So what will be the volume of the thin thickness? It will be nothing but area of cross section into the thickness, which is dx. So that's the volume, okay, into V, the whole thing divided by dt. But wait a minute, I just got dx, I got dt. What is dx by dt? Rate of change of x with respect to time. That's velocity, my warriors. So therefore this will be rho a into v. So it will be rho a v square. So that is your thrust force. Very, very important. Remember this formula. So whenever a liquid with speed v comes out, the thrust force is rho a v square. Excellente. Okay, say friends, if you're going to spam, I'm definitely not going to answer. Okay, cool. Yeah. So why fluid is coming in the rocket? Fluid means gas or liquid, Selva Kumar. So why does the rocket go up? The rocket goes up because of Newton's third law. There is some hot gas. When a gas is hot, it has very high speed. So that hot gas comes out with very high speed. So by Newton's third law, there is a reaction force. So force on the fluid is also the force by the fluid on the rocket. And that is called as the thrust force. I hope that makes sense. Yep, Newton's third law of motion. Yep. What is rho? Rho is density, bacha. Because mass is density into volume. Okay. So how did we get this over here? Remember this, I got it by mass is basically density into volume. Rho is the standard symbol. Density into volume. You should know the standard symbols. Rho is density, sigma is mass per unit area, lambda is mass per unit length. Standard. Yeah. Very good. Vijay, if you're understanding my mock test sincerely, not just an idea, but you will in fact score really well. But if you want to make sure that you will score well, then please join the KVPY crash course, which has 15 mock tests and 20 assignments of each subject. So please join it because it is for hardly, I think, some 2000 rupees or 2500 rupees or something like that. So go ahead, join the KVPY crash course. Okay. Now going to the last part. Thickness into area will give you the volume. Correct, Selva Kumar. Yep. Yes, Aditya Narayan, I can hear you. I can hear you also. I can see you also. Yep. Alright. Chalo. So Muhammad, just leave a comment after the video and I'll definitely let you know which is the best book for JEE Mains and Advanced, so that everybody else can also get benefited by your comment. Okay. So just leave a comment. Okay. I'll respond to it. Lambda is latitude, lambda is wavelength, lambda is linear mass density, lambda can be many things. Okay, so just because there is one symbol, it can be used as a different physical quantity also. Don't worry about it. Okay. Oh my God, Harshal, you got late. No problems. You can watch the replay. But today's lecture had a lot of amazing concepts, and probably you will watch it after this session ends as a replay. Now, variable mass system. See, till date, whenever we wrote Newton's second law, we wrote it as F is equal to mass into velocity derivative, basically mass into acceleration. F is equal to ma. That's our standard equation. But here is the thing. Here is the thing. When mass is not constant, then it becomes a problem. Exactly, Selva Kumar. What about gravity? We are going to talk about gravity in the next problem. The previous question only calculated the force by the fluid. Force of gravity was not taken into account. Now we'll take account the gravitational force also. So when I say thrust force, gravity has no role to play in it. Ignore that. So that's why I just calculated rho a v square. There is no g in it. Now, when the mass is itself changing, then understand you need to make a small modification in the Newton's second law. And what is that modification? Here it is. Because force is rate of change of momentum, and momentum, I told you, is mass into velocity. Since mass is not constant, you cannot just take it outside. You have to use the product rule. What is the product rule? When you have two functions which are varying, then the first function into the second function's derivative plus the second function into the first function's derivative. So this is the modified Newton's second law, which takes into account the variable mass effect. When mass does not change, this term becomes 0 and you will just have m into a. Remember, dv by dt is nothing but acceleration. That's it. Is that clear? Very good. Very good. Excellent. How can mass change? Very interesting question. When a rocket ejects the gas, what is happening? The mass is decreasing. When there is a railway wagon and from the top you are adding some goods, mass is changing. There is an escalator which is moving up. People are going on the escalator or loading out of it. Mass is changing. There is a car which is moving. Slowly fuel gets burned. The mass is changing. There could be so many examples where the mass changes with time, and that's why there are peculiar examples where mass changes. Generally, more or less the mass remains constant. Okay, so even if a car burns its fuel, the fuel's mass is very less as compared to the car's and the passenger's mass. So generally you ignore it. But if you want very precise calculations or systems where the mass changes significantly, example a rocket, because the major part of the rocket is the fuel. It's not the other body, it's the fuel which is major part. So that's why you need to take into account the mass change effect. Is that now clear? Is the weight changing in the elevator? The weight changes in the elevator because of the pseudo force or the apparent gravity, not because of anything else. Is that clear? Yes, King, I do remember, but I don't know what's your complete name. Maybe you can tell me your name. Yep. All right. Yes, in elevator only the weight changes, mass does not change. Correct, bacha. Okay, so keep this in mind and then we'll see the rocket equation. Okay, so remember this equation. What is the complete equation, my warriors? The complete equation is force is m dv by dt plus v dm by dt. What is this dv by dt? It's acceleration. What is this m? Mass at that instant. Plus, what is v? V is the velocity with which the mass is ejected, and dm by dt is the rate of change of mass. What is dm by dt? Rate of change of mass. Very good. So, sir, can mass be transformed to gas, right? How is change? I can't understand. Selva Kumar, very simple, man. Gas also has mass, na? Gas is not massless. Liquids have mass, solids also have mass. So when gas comes out, it's basically some mass only, right, which is coming out. So that's what I did in the previous question. Okay, so when gas comes out, mass is only coming out. What is deed? What? Oh my God, Ashin, that's derivative. It is not distance. Okay. Sir, gas only not have volume. Everything has volume, Vijay. Gas has volume, liquids have volume, solids have volume. Only empty space does not have volume. Okay, Vijay? Is that clear? Very good, very good. Is that clear? All my warriors, please let me know. Then I will go to the last equation. Everybody give a thumbs up. Everybody give a yo. I've answered all your doubts, bachalo. Okay? So that's the beauty of the live classes. You can interact with me. You can get your doubts cleared. Very good, Vijay. Very good, Harita. Very good, Ashin. 100% clear, says Ashin. Chandan. Also you, Vijay, Mohammad. Very good. Now let's talk about the rocket equation. It's such a nice, amazing, scene to watch a spaceship or a rocket fly. But now we have to get a simplest form of the rocket equation. I'll tell you what this rocket equation is. Our aim is to find velocity as a function of time. That's what the aim is. What is given? Initial velocity is v0, okay, and this rocket ejects the fuel, okay, this rocket ejects the fuel with speed speed of ejection. The speed of ejection is basically u, and the rate at which the mass comes out, rate of change of mass, or rate of ejection of mass, I can say, rate of ejection of mass. Basically, I'm talking about dm by dt, that is r. So that rate is r, small r. Fine, fair enough. Very important terms. Initial velocity v0. Speed with which the fuel comes out, the gases, burned gases come out, is u. The rate at which the masses, kgs per second, how many kg of fuel gets burnt per second and is thrown out, is r kgs per second. What is ejection? Ejection is throwing out. Eject, you fly out, you're ejecting. Inject, you're coming in. Eject, it's coming out. Okay, so these are two different words. Okay, so now what are the different forces? First force, I just have gravity, which is downwards, mg. This rocket will have some speed, and obviously it will have some acceleration. That acceleration will be dv by dt. This rocket will have some mass. This current mass, okay, if I call it as m, this mass will be initial mass. Let's say it is m naught. Okay, so like we had initial velocity, let's say the initial mass was m naught. If initial mass is m naught, think what will be the mass after some time t? Think, my warriors. If initial mass was m naught, after some time t, what will be the mass? Because the rate at which the mass gets burnt is r kgs per second. R kgs is burnt per second. So in t seconds, r into t will be burnt and ejected out. R into t will be ejected out. So what is remaining? Out of m naught minus rt is ejected out. So remaining is only m. Is that clear, my warriors? Think about it. RT gets ejected out. So remaining current mass. So this is the remaining current mass will be m, which is initial mass minus the mass, which is this one is ejected out. This is the one which is ejected out. Fair enough. Okay. So why do we need a not designation? Generally, the subscripts are used to tell the information additional to the variables. So if I write m0, it looks mathematically like m into 0. Or if I put mi, it looks like m into I. So when I put a subscript, then it does not change the variable, or you do not multiply it. And if I put it on the top, it becomes m raised to I. So that's a complete different mathematical meaning. So when I put it as a subscript, then you are not doing any mathematical operation on it. It's just symbolic to the current situation or state or whatever that phenomena is. So that not generally stands for initial or original or the previous value. Is that clear? Yes, I do remember every one of you. So then I'm very good. Okay, clear? Chalo. Now let's start from our governing equation. What is our governing equation? Force is equal to m dv by dt plus v. Oh, in this case, this v is nothing but u, okay, into dm by dt. Why is this u? U is the speed with which the mass comes out, and it is clearly mentioned that it is u. Okay, let's start writing this down. What is the force? The force is mg, but it is not up. Where is it? It is downwards. Yep. So it is downwards. Everybody clear? So which book I refer? Kamalnath, I refer to many books, bacha. There is not one book. I'm a teacher. I'm supposed to refer to many books. But for you guys, H.C. Verma is more than enough. And Tattva. This force will be minus mg. Think about it. Okay. Is equal to m dv by dt. Fair enough. Plus u. Okay. Now comes the critical part. The rate at which the mass is ejected, dm by dt. If I say it is r, that r should be negative then, because the mass is decreasing. So strictly speaking, dm by dt is basically minus r. Dm by dt, rate at which the mass is ejected, it is coming out. Remember, the mass is decreasing. That's why I should put a minus sign. That's why you can see this minus sign also has come. Mass is not increasing. dm by dt, change of mass per unit time, is negative because mass is decreasing. Clear till this point? Yep. Sir, I said force is rho a v square. Correct, Selva Kumar? That's very true, bacha. Rho a v square is the force. I can do it via that way also because I've just calculated it, but I'm showing you right from the basics again, Selva Kumar. Okay, if I do it via rho a v square, the equation might look a little bit complicated in this case. So that's why I'm doing it right from the basics. Number one. Number two, rho a v square is the force only because of mass ejection. When I write F is m dv by dt plus u dm by dt, this force is not because of variable mass. This force is the other force apart from the mass ejection. What are the other forces? Normal, tension, friction, spring, gravity, etc. So all the other forces comes here. This part takes care of the thrust force. Is that clear? Is that clear? Okay, this part is taking care of the thrust force, u dm by dt. I hope now it is clear. Okay, if it is increasing, it will be plus dm by dt. Excellent. Yes, good you asked that question. Sir, why is that thrust force not rho a v square? Why is it minus mg? Okay, great. Chalo. Now, so I should put dm by dt is equal to minus r. Okay, mu is a constant, r is a constant. So how about taking it on the other side? Okay, so m dv by dt will be mu r minus mg. So take m below and probably okay, so take m below. Let's see what happens. So dv by dt is equal to mu r by m, okay, mu r by m minus g. This is what I will get. Interesting. Now let me take dt on the other side and see what do I get. So dv will be mu r, both are constants. M is m naught minus rt from here. dt goes on the top. So dt divided by m naught minus rt. Interesting. And minus g, this dt has gone on the top. So minus g dt. Check this out, if this is clear. Now the reason why I wrote this in this way is because now I can integrate it. Look at this, integral, integral, integral. Can you see that? I can actually add integral symbol everywhere. Now the limits of integration. Initial velocity is v naught. That means when the value of time, do you see the variable with respect to which I am integrating? It is time. So when the time is 0, the velocity is v naught. When the time is t, that time the velocity is v. That's what I will write. So the limits go according to what is there on the RHS and left hand side. So when the time is 0, the velocity is v naught, and when the time is t, there is some velocity v, which I do not know. Okay, so let's try and solve this equation and see what do you get. Okay, so first of all, integral of dv. What is integral of dv? It is just v, right? Everybody clear about this? Very good. Yes, Gokulnath, we can easily integrate it. So integral of dv is v. So it will be v minus v naught is equal to mu r are constants. Now you might be wondering, sir, what is the integral of this? Sir, gravity also varies with height. Very perfect question, Selva Kumar. We are ignoring the effects of gravity. That is why it is called as rocket science. Because gravity will also change. There is rotational effect of the earth and there are viscous forces. That's why it is called as rocket science. We are keeping our model of rocket relatively simple because the knowledge of integration that we have for 11th and 12th can only make us solve these kind of equations. For solving the effects of gravity, viscous force and other things, then the equations become so complicated that the maths that you learn in 11th and 12th will not be sufficient. I hope that makes sense. Sir, is it u or mu? It is u. U is speed. It's not mu. U is meters per second. Okay, it is u meters per second. Okay. Now, once you got this as mu r, and now let me tell you one important integral. Integral dx upon a plus bx is ln a plus bx, the whole thing divided by b. This is the formula which you should know. In case you do not know it, just use it. You will anyways learn it in your 12th standard. Okay, let's try to do this integral. So you can see over here, a is m naught, b is minus r. Can you see that? A is m naught, b is minus r, and t is x. So what will the integral be? It will be ln, and you will have m naught minus rt, the whole thing divided by minus r, and the limits of the integration will be here. You will have 0 and t, and minus g t minus 0. Okay, so that is what I got till here. So let's see what do we get next. So v minus v naught is equal to r goes, so minus u will come over here. First put t, then put 0 instead of t. So you will have ln m naught minus rt, okay, minus, now put 0. When you put 0, rt will become 0, so minus l log m naught. That is what you will get. First put t, calculate this value, then put 0, then see what is the value. So log a minus log b is what I got, minus gt. Okay, so I'll get v minus v naught is equal to minus u. Log a minus log b is log of a by b. You know this, correct? So this will be ln m naught minus rt divided by m naught, and this whole thing minus gt. Okay, interesting. Bring it on the other side. So therefore v will be equal to v naught minus gt. Because I have minus sign here, if I take it inside, okay, if I make it positive, then I have to flip this. So it will become log of m naught, these are logarithms rules, okay, minus m naught minus rt. I think that's it. That is my final answer, I believe. Okay, so this is my final answer. V is this equation. So this is the equation of a rocket, neglecting viscous forces, neglecting rotational effect of the earth, and neglecting effects of gravity, variation with height. Very interesting. Yes, logarithm also applied. Will there be intensive calculus course in aeronautical aerospace engineering programmed in college? Yes, Vijay, no matter whether you take aerospace, whether you take chemical, or whether you take metallurgy, you have 4 semesters maths. So maths will come in 4 semesters, and they are very complex. So if you want to become an engineer, obviously you need to be good at maths, integrals, derivatives, matrices, differential equations, and all the other operations, obviously. Yeah. I don't know logarithm, but I know calculus. Selva Kumar, okay, no problem. Please learn calculus and logarithms both, because you will see a lot of trigonometry and logarithms as well as algebra is used in calculus eventually. So you should be good at trigo, logarithms, binomials, and even algebra, all of this. Okay, so that's the equation. So now I hope you know why it is called as rocket science. Have you heard that joke? Oh, it's rocket science. What does it mean? It means it's very complicated, because when you take into account all the effects, the equations come out to be even more complex. This is your first homework question. Force of 10 Newton acts on a body. Please put it up in the comments. This is your second homework question. Please again put it up in the comments. So let's see who and all have solved the homework for the last lecture. And let's just have a look at the comments as well. And then I'll also show you how you can join our courses. And where are we? Yes, center of mass. That was a one-shot marathon session. Okay. And let's go below, and we have Kimin, HC Verma and Tatwa. Yes, you had asked a doubt, I answered it. Hey, welcome, Ishpreet. And I think I have to reply to innovation. Yes, I'll reply to innovation. Sir, I'm studying in 11th standard. Which book is the best for JEE Mains? Objective Physics for Engineering Entrance by DC Pandey or Understanding Physics by DC Pandey? If you want to understand physics, then go via HC Verma. To solve problems, use DC Pandey. Objective book, you have unit wise, some 4 or 5 books are there. Use those books for solving problems. Understanding will not come via DC Pandey, it will only come via HC Verma and NCERT together, and class notes. Thank you, Arita. Well, BB5 had asked a question. Very good, Saja. Very good, Ishpreet. Very good, Yash. All right, I like this comment. And MD Riaz, very good. Harshil, Harita, Vignesh had asked it out. Thank you, Anil, Gokulnath. Thank you for all the lovely comments, and thank you for enjoying. Oh well, I'll teach in Microsoft very soon, hopefully. I'm a NEET aspirant. क्या मैं आपके lecture ले सकता हूँ? Definitely ले सकते हो, देख सकते हो, enjoy भी कर सकते हो. Yes, why not? Definitely, बच्चा. Now in any video that, let's say, you are watching right now. So if you are watching this video, where is it? Yeah, so you're watching this video. What you need to do, how do you join the courses? Because some of you are asking. See, there are different types of courses. One is JEE 2-year course, CBSE Term 1, CBSE Term 1 and 2, Grade 11th and 12th Science. What is this? This is only pure CBSE course. But I think most of you will be interested in JEE course. JEE course also includes CBSE related assignments and mock tests, so you don't have to pay for it separately. So just go over here. This is the crash course. Now it says 21 to 23. That means the batch will start on Monday. Okay, the batch will start on Monday. You will be prepared for 11th standard before February, March. And what will happen after February? You will have revision, you will have some mock tests, you will have lots of assignments given to you. And then from April onwards, you will be again in a proper long-term batch for the 12th standard. So it's a 2-year program in a way, and it will go until the last day of JEE Advanced, whichever is the last date. Okay, we cannot tell it now. Now, you will get live classes, recordings, test series, assignments, doubt solving. Even on the mobile app, if you wanted, go for the classic version, because that's what you get in the classic. And in the plus, you will get the personal mentorship. What is the course fees for 2 years? It's 53,999 rupees. That's amazing. That's probably 1/5 or 1/6 the cost that one will pay in a regular offline coaching. Number one. If you feel that, no, I want to try it out for 1 month, fair enough. Try it out for 1 month. You can see there is some offer going on. So when you use my coupon code SHHPRO, you can try it out for 1 month. Just enter your phone email, log in, you will get it. If you want to buy the complete course, that option is also there. And some of you might be like, sir, I don't have money to pay this. It's okay. You can pay it via EMI option, which is 3,000 rupees per month. So all options are there. First option, buy it for 1 month, try it out, and then if you like it, continue, pay only the remaining amount. Second option, buy the complete course for 54,000. Third option, buy the complete course but don't pay complete amount, you pay it monthly. All options are available. I hope this is clear. So can I check it out for if it's good for 1 month? Definitely, Vijay. You are completely free. Just try it out for 1 month. If you love it, continue. If you don't like it, no problem. You can watch me on YouTube or you can join some other coaching. You are completely free. I'm not forcing anything. Okay? Chalo. So, are the entrance exam other than KV for people who want to do research? Yes. There are. Basically, you have Olympiads. Yeah, all these Olympiads. Okay. Is engineering good, physics good for research or not? Yes, definitely it is very good, bacha. Definitely. Okay. So, I hope to see all of you in the pro subscription. You will also find my courses for 11th standard, including derivation, HC Verma, Irodov, and also problem solving. You will find 4 micro courses conducted by me alone, and there are so many other teachers, and let me tell you, there are batches in English. Yep, so that should be your plus point. So go ahead, join it. I'll be waiting for all of you, and do not forget to like, share and subscribe to our channel, and like this video, because that's what will give us the support. How do you choose teachers? So you will for sure get the best teachers. All the teachers are similar. But let's say for some reason you do not find some teacher convenient, then you just have to write an email and you can change the batch. All right. But it might not be possible that all the teachers whom you like are always teaching the same portion at the same time. So you can probably choose between those batches which are running in parallel or which are having similar portions. Don't worry. I know the teachers who are teaching right now are excellent, and all teachers are very experienced. All teachers are from the top-notch colleges with lots of experience in producing results. Go blindly with it. So just start your preparation. Don't waste your time anymore. Okay, chalo. So what is the purpose of using D, delta, etc. in these type of equations? Ashin Sibu, it's very simple. D is used when the value is infinitely small, but it cannot be measured. So if I tell you the smallest distance possible, it is not 0. Okay, some smallest distance which is not 0 is not 0. It's not even 0.1. It will be 0.0000. I don't know how many zeros I'll put. So that is D. Okay, that's a symbolic way of saying it is an extremely small value which cannot be measured, which is not 0. Delta is used when the value can be measured. Let's say 0.2 seconds, 0.5 seconds, So it's a change in the value or small value which can be measured. So that's the difference between them. And D is used for derivatives and delta is used for change which are finite. Yes, Selva Kumar, rocket related problem, I just did it. So that's how you need to do the problems, Selva Kumar. So whenever you see questions on rocket, you will be using that equation or the method of that derivation which I just did for the rocket propulsion. Is that clear? Yep. So Vishnu Devari, I think you should go for EC in NIT Warangal. All right. So how much percentage in JEE Advanced to score to get under 500? Pranish, you should be definitely above 70%, 60%. But some papers are very difficult. So that time probably, even 50% marks can get you under 500 rank. Sometimes the papers are very easy. That time your score should be percentage wise above 70, 75%. So it depends on the difficulty of the paper. But generally it goes anywhere between 50% to 75% around that. Okay. Chalo. I hope I have answered all your doubts. I hope Selva Kumar, you got your query cleared. Okay. Chalo. Take care. Bye bye. Thank you for all the love and have a great time. Please have your dinner. This was your Capto Shreyas. Yeah. Please hit the like button as well. Hasta la vista.